come to light at Toyota Bushoku that M8 smooth barrel proximity sensors are failing due to impact damage. Now, in looking at the pictures of where the sensors mounted, it seems as though the mounting hole is a little bit oversized for the smooth barrel. Talking to some of the maintenance staff, what sounds like is happening is the sensor is moving either too close to the part, contacting the part and breaking, or it's moving out of range, which then requires it to be adjusted. Given this information, the most important thing we're going to need to do is secure the sensor to ensure that it's optimizing its sensing range and not coming loose and needing adjustment. A couple of ways that we can do this. We can use an M8 tap to tap out the inside of that mounting hole and switch to a threaded M8 sensor if possible. In the vending machine currently, there is the HTM one-piece stainless steel proximity sensors with a pigtail to the same connector that you're currently using now. What this is going to do is allow you to use the threading and the lock washers to securely mount the sensor so that it doesn't come loose. As well, you're going to be employing the stainless steel sensing face, which is going to help the sensor stand up a little bit better to any impact or abrasion that may occur during production. In this particular application, there seems to be a lot of room around the sensor face, which may allow us to use an unshielded M8 sensor. By switching to an unshielded sensor, we're going to increase the sensing range from 2 millimeters up to 4 millimeters. We're still going to take full advantage of the threading and the lock washers to lock the sensor into place so that it doesn't become loose and need adjustment. But the extra 2 millimeters of sensing range are going to allow us to position the sensor even further away from the target, thus increasing the likelihood that it's not going to be hit. If the current mounting hole is too large to use an M8 tap to create the threading, what we can do is go up to an M12 tap and make the mounting hole appropriate for a standard M12 sensor. This is going to allow us to utilize the threading to lock the sensor into place, but it's also going to now provide us with the opportunity of going to 4 millimeters, 6 millimeters, and even 8 millimeters of sensing range, which may be our best option to fully eliminate the chance of impact with this sensor. At HTM, we specialize in reducing sensor-related downtime for automotive manufacturers. Recently, we undertook a preventative maintenance project at a large automotive MIG welding factory in Toronto, 250,000 square feet. By examining the tooling, making adjustments to the sensor mounting, and putting in the optimal sensor for each application, this manufacturer was able to reduce sensor and cable-related downtime by 60%. The best thing to do may be to have one of our HTM technical specialists come down, take a look at the application, and see if there are other factors that we can take into consideration in providing the optimal downtime reduction strategy for this application.